Here's some more types of motors. This would be considered just a DC motor, but this is a small electronics one. Now what's missing from this is a brush set. Every DC motor has a brush set. It's just two pieces of carbon that they energize, and it basically becomes the opposing magnets. Thing about a DC motor is if you don't plug that in under load, or if you let it run too long, it will do something called runaway, and that's basically when it spins so fast that it will tear itself apart. DC motors will do that. The reason why this has 3 little capacitors tied to it is because in electronics you have to compensate for that initial inrush. So this will provide that initial inrush of voltage to get this motor started. This is a servo. Actually, this is a high, what do they call it? A high torque servo. So this little thing doesn't look that big, but this will move incredible amounts of weight. I mean, you'd be surprised. Now, servos used for precise moving. This is another robot application, but you pretty much charge, say I want it to move from 0 to 30 degrees, and I want it to move 0 to 30 degrees in a half a millisecond, so that controls the speed. And this is basically, you know, you can put whatever you want on it. It's just basically linear motions, just like a motor, normal motor. This stepper motor is the same, but this is for extremely precise movements. I don't believe that these, I don't think these have the torque rating something like this would have. The problem with these two is they require specialized technicians. They require drives, they require position controls, they require programming, and not everybody can program a motor like this. You know, Andy, who played with Peepaw's brakes once or twice, can change a motor like this. These ones, not so much. These ones are much more complicated.